mainly using three types of hardware descriptive languages that is used to code in the hardware. Like how you are dealing with the software like Java, Python and C. Here in this hardware descriptive languages we are using Verilog, System Verilog and VST like that. Using that we are going to code for the hardware descriptive languages, like to code and build a specific IC that performs for a specific operations, like basically to create a chip that works on specific operation, for example like CPU or the GPU, and for that we are using this languages, and we are like trying to build a chip. So in the front end part, like you can see with these languages we are trying to build a IC. So for that here in this we have an OpenPower Foundation. So which is Ganeshan sir is Vice President in the OpenPower Foundation, which we collaborated with IBM, and they come up with a foundation where they had come up with this chip design, because in the chip design industry now creating a chip and manufacturing all those till now it has been closely monitored. Not all the students are like know like what is happening in the chip design industry. So with this OpenPower Foundation, they just launched this processor like microwatt. It is one of the open source processor, like the CPU processor. How you have your system like the Intel and AMD processor like that, but it is a tiny processor. But they had fully open sourced it with the OpenPower Foundation. That has been built under the architecture of Power ISA. In older, like when you look back into 30 years back, like the IBM and Apple, they all collaborated and they make a chip where that chip only were being used in the first the Apple system and all. Now they had come up with their own chip, but all these chips that were created from the IBM, that were built from the Power ISA architecture. So that is instruction set architecture, which is a set of architecture to build the processor. So now the IBM has launched its the microwatt processor, which is fully open source. So the students and the researchers can see like how the processor has been built with this OpenPower processor, like the Power ISA, which is like in the previous years, like they manufactured as a real chip. So using that, using this microwatt, like you can get and work with how the real CPU has been built. So it is written in the language called VSTL. So here when you enter into the course here, so we will teach you like how we build a processor from end to end. Then we also like from the microwatt processor, it is a CPU kind of a processor. So where we put a Linux into this processor. So for that, to program it, we are not mainly like program it into the ASIC chip. That is, we have two types of chip. One is ASIC and FPGA. So where the ASIC chip is, once you program that, it can't be reprogrammed. So it will use it for the specific operations. So when you build a chip in a factory, they build a ASIC chip in a like thousands to millions of chips at the same time. So once you programmed it, you cannot reprogram or again reach it. So the whole manufacturing things will get waste. So for that, what we will do, before getting into the actual ASIC chip, we use a FPGA chip. That is also like the same feature, but this FPGA will help you to reprogram the chip multiple times. So using the FPGA board, like we use the code like the process like what we develop, and then we flash it into the FPGA board, and we see how this has been working with the real world. Then if it is working fine, then we move it into the ASIC chip. So before mainly program it into the ASIC chip, we try to program it into the FPGA board. So here in our company, like we have a FPGA board called the RTK700T. So using that FPGA board, you can try your code and then try to flash it and then check how it has been working. Then likewise, I said this microwatt open source code, like you can also try that the microwatt code and then import it into the your FPGA board. Then the FPGA board will act as the processor. Inside that, you can put Linux OS into this. Like in the processor, you can build a Linux OS. Then you can use it, like you can build a complete system like kind of thing where you have your own processor and OS. So here, like we also tell you like how to get the processor and work and then flash it into the FPGA board. Likewise, how to create a Linux image that is specifically for the processor which I have built. then that also we flash it into the FPGA code, and then we see how this Linux has been booted to the processor that we have developed. So that is the one thing that we cover in the front end part. And this for this RTL coding, that we call this front end code part as RTL coding, that is register level of transfer. The register level of transfer, that means like the register is like where your information gets stored in the like we store the information in the register. So like RTL is like register transfer, that is transferring the from one registers to other register, like that, nothing like that. We call it as a RTL level of coding, that is in the front end part. Then we also teach you the back end part. So in the back end part, we teach you how to build a chip. So where like in the front end, I said we are writing the RTL coding. We are flashing it into the FPGA mode or like the ASIC chip, and we build a process. So in the back end part, we will see how we build the chip. So for that we call it as a RTL to GDS2 conversion, like where you will get a layout kind of a thing. That is, the layout means like how before we build a building, like you have a blueprint, like where to build it, like for that. So likewise, to create a chip, we have to create a layout, like where this component should be placed and what the size should be and how much power it is taking, all those things that as a chip designer we used to design. So that process of developing a chip, that is called that will be done in the backend part, that is we call it as RTL to the GDS2 conversion. So for that in the market, like they have using the tool like Cadence and Synopsys, like you know the companies, they are the big companies, they are using those tools, like we built mainly the chip. By this OpenPower Foundation, they also came up with another one, EDA tool. So just to build this design, like we use the EDA tool. They come up with a tool called OpenRoad. So using that OpenRoad tool, you can build a chip from that. You can also create a layout of a chip. So after you build the layout, like then that layout you will send it to the factory for the fabrication. They using that layout, they will make a chip out of it. So you will have your RTL code to convert it to GDS2 flow. You have some step-by-step flow, like the flow planning. First you will take like what size the chip need to be, then like the components that will come from the electronic boards. I am not going in there. So like placing those components and then finalizing the chip, and then you will get a final like that layout that you call it as a tape code. So where that is ready for making a chip, that we call it as a tape code. So then if your design is ready for a tape code, then you can send it to the factory and then you can make a own chip out of it. So that thing also you can do with this open source company. It's a fully open source tool with the OpenRoad, because in the market, like we are using this Cadence and Synopsys, that is the license cost is very high. So it also they won't give for the student access. So for this, if you want to try in this college also, it may cost around 30 to 40 lakhs around the for any tool. So to have aware of that, how this backend the chip is been working, this OpenPower Foundation, they also giving the EDA tool, open source tool. Similar to that, you can also see and work with the backend flow. Then also, like we 3 months back, we collaborated with the IBM and conducted a hackathon where like 100 participants were connected all over the world, like where we selected top 3, and then they had successfully come up with a demo. Like they fully created a chip with the open source microwatt processor and with the OpenRoad tool, and they had created the top 3 finalists. They had a ready chip for the tape code. So connections are also tied with some companies like Chip Foundry and trying to get a complete chip out of it. So our goal in the 2026 is to get like this 100 tape codes. So right now we just with the hackathon we just got 3 new ideas to create a chip like 3 tape codes. Likewise with this open source tool and thing, like we trying to get like 100 new ideas and like creating 100 tape codes. So that is the plan here. Yeah. Yeah, so as I said,
Because I can see in AI, previously we were doing all manual tasks, now in AI it is automatic. Likewise, chip related industry, what advancement they have and why we are using open power. Because open power we have LLM models, right? Free source LLM model.
That is different. This is OpenPower Foundation. That is, they come up with a foundation and they giving the industry like open source the codes, because the processor, if you take any processor like the Intel or the AMD processor, you can't see how they have coded. Likewise, how you see the software, like if you are creating a web page, you can't see the source code. Because in the open power you have the source code of some projects. I said the microwatt, it is a CPU processor, so that source code you can easily available, and you can using that processor you can build your own processor, or like you can add some features and then create a chip like in IIT they are also using, like I said, for the power ISA architecture, using that these chips are available. Likewise, we have similar type of architecture called the reseach. So using that
before this open power, there are the
companies will only so the individuals or the students or the researchers can't make their own. So if they want, they have to go inside the company. They have the limited access. They can't create their own chip. Only, but now we can get. Now only because India also before that we didn't have any own chip. Now only we are trying to enter, because like this architecture, these are all closed source. Now they have open source. Likewise, we have RISC-V architecture that they now they have completely given as an open source. So only the IITs are also trying to build their own chip from them.
So because of this open power, before only companies were used to create the chip. Now anyone can
access and then so this is one type of architecture. The microwatt is being used. Likewise, we have the RISC architecture. So the IITs right now they are using the RISC architecture and they are trying to create a chip. They are also in the process, not fully come up with one chip, but they are also creating it. Likewise, the CDAC also creating. They see that before, like they had created a Arduino kind of a board from India, fully made by India. So the goal is here is now we just want to make a fully made in India chip. That is what IITs they are doing. But before we didn't have the boards.
TCS also planning to enter the semiconductor field. I think so. Assam with the more than entering the field.
Now anyone can create a chip because of this open power.
That is good for the industry. We don't have any competition. No, we don't have any competition. We just have only two big companies. Like you can just say this only Intel and AMD, the two only processor. Now only AMD. Only two processors has been used. If you see for 30 years, like you only have Intel. Now only AMD is moving, and now in the recent years, like in the system like computer, you have AMD processor. But what it is, they are only the ruling the market. Then you can't see what they fix the price, that is the price. So if all come and collaborate only, the competition will get increased. Then if we launch our product, like how in NASA they are also launching the market, but in ISRO, like we are making the chip, right? So if we make a chip in India, that will be more cheap than Nvidia and assembly. That will reduce the cost of the computers. So it is always good to have more competition. But before it was all closed source. Now all are coming as an open source, so it is also in development. So we come and we can create the own chip. This is the main goal.
Whatever you create in the computer system, it's like an image.
Means
Like in the system, you have like an image, whatever you create. Even in the application development.
application development.
Application la the chip.
ப்ரோக்ராம் ரன் பண்ணுறதுனா எப்படி இந்த ப்ராசஸ் கோடில் இருக்குன்னா நம்ம கம்ப்யூட்டர் நம்ம ஒரு லேப்டாப்பே ரன் பண்ண போவாங்க. அதுதான் சிப்போட ஆப்ரேஷன். அட்வான்ஸ்மெண்ட் என்ன அப்படின்னு சொல்லிட்டு பார்த்தீங்கன்னா ஸ்பீட் தான் அட்வான்ஸ்மெண்ட். இப்போ வந்து ப்ரீவியஸ் இயர்ஸ்லாம் பார்த்தீங்க அப்படின்னா ஒரு லேப்டாப் எடுத்தால் 3 டேப் அதிகபட்சமாக ஓப்பன் பண்ண முடியும். 3 டேப் யூஸ் பண்ணாலே லேப்டாப் ஃபுல்லாக ஹீட் ஆகும், ஹேங் ஆகும். இப்போ நான் என்னோட லேப்டாப்பில் பார்த்தீங்க அப்படின்னா 24 டேப்ஸ் 25 டேப்ஸ் ஓப்பன் பண்ணி 3 days ஒர்க் பண்ணுற லேப்டாப் டெவலப் பண்ணாங்க. அதோட ஆப்ரேஷன் என்னன்னா சிப்போட ஆப்டிமைசேஷன்.
So நம்ம வந்து like direct பேக்கெட் இஸ் ரன்னிங் அண்ட் ஆப்டிமைசேஷன்
காசு அதிகமாக ஆகும். அந்த மாதிரி ஸ்பெசிஃபிகேஷன் தான் உள்ள கொண்டு வந்தது.
Sorry, I don't know. New to this.
இல்லைனா இப்போ பேக் எண்ட் பார்ட்டில் நான் சொன்ன மாதிரி இந்த ஓப்பன் ரோட் யூஸிங் தட் லைக் வி கிரியேட்டிங் த லியோ. ஸோ அதெல்லாம் இன்னும் நாங்கள் இன்னும் சின்ன சைஸ் நேனோமீட்டர் சைஸில் நம்ம இப்போ சிப் டிசைட் பண்ணுறோம். இப்போ கரண்ட்லி 2-3 நேனோமீட்டர்ஸில் பில்ட் பண்ணுறாங்க. ஸோ லைக் வி கிரியேட் சிப் ஸ்மால் நேனோமீட்டர் லைக் அதான் மொபைல் ஃபோன்ஸ் இது இன்னும் நம்ம சின்ன சின்ன டிவைசஸில் நம்ம சிப் பண்ணலாம். ஸோ பை கிரியேட்டிங் த சிப் ஸ்மால் சைஸ் லைக் பவரும் நமக்கு ரொம்ப எஃபிஷியண்ட்டாக யூஸ் ஆகணும். லைக் நாட் த ப்ரீவியஸ் லைக் பிக் சிப்ஸ். ஸோ இது மாதிரி நிறையா எஃபிஷியண்ட்டான இருக்குது. ஸோ அதுக்கான இதுவுமே முன்னாடி வந்து இந்த டிசைன் பண்ணணும்னா அதான் இப்போ சொன்ன மாதிரி அதுக்கும் ஒன்லி டூல்ஸ் மெயின்லி யூஸிங். இன்னும் இந்தியா வந்து ஃப்ரண்ட் எண்டில் பெருசாக வந்துட்டாங்க. பட் பேக் எண்டில் இந்த ஃபேப்ரிகேஷன் நமக்கு கிடையாது. இங்கே நம்ம லேஅவுட்லாம் நம்ம டிசைன் பண்ணாலும் நம்ம வந்து வெளியில் தாய்வான் அந்த மாதிரி அங்கே அமைச்சு தான் நம்ம சிப் மேனுஃபேக்சர் பண்ணுற மாதிரி. ஏன்னா சிப் மேனுஃபேக்சர் பண்ண கட்டுறதுனாலே அதுவே ரொம்ப காஸ்ட்லி. ஸோ பட் இப்போ தான் இந்தியா குஜராத் அந்த மாதிரி இடத்துல பில்ட் பண்ணிட்டு இருக்காங்க பேக்கெட்டில். ஸோ ஃபியூச்சர் சிப் மேனுஃபேக்சரிங் இந்தியாவில் இருக்கும். ஸோ மெயின்ஸ் இந்த IBM அவங்களோட கோர் இந்த ஓப்பன் பவர் ஃபவுண்டேஷன் வந்து நாங்கள் ஓப்பன் சோர்ஸ் தான் வி ஆர் கிவிங் த ஆக்சஸ். லைக் யூ ஜஸ்ட் ட்ரை அண்ட் கெட் த சிப்.
பெஸ்ட்டாக ஒரு சிப் டெவலப் பண்ணோம் அந்த டிஎஸ்எம்சி மாதிரி வைக்கணும்னா ஹண்ட்ரட்ஸ் ஆஃப் ஏக்கர்ஸ் தேவைப்படும். அந்த நெக்ஸ்ட் வந்து ஹண்ட்ரட்ஸ் ஆஃப் மில்லியன்ஸ் இன்வெஸ்ட் பண்ணணும். இல்லை கவர்மெண்ட் கோஆப்ரேட் பண்ணால் மட்டும்தான் அந்த மாதிரி ஒரு இண்டஸ்ட்ரி டெவலப் பண்ணணும். ஹார்ட்வேர் டிஸ்கிரிப்ஷன்
அதுக்கு தனி லாங்குவேஜ்.
இப்போ நம்ம சாஃப்ட்வேர் லாங்குவேஜ் எடுத்துக்கிட்டிங்க அப்படின்னா ஃபுல்லாக சீக்வன்ஸில் அடுத்தடுத்து நடக்கும். இப்போ ஹார்ட்வேர் லாங்குவேஜ் எடுத்துக்கிட்டிங்கன்னா எல்லாமே பேரலாக நடக்கும். நம்ம வந்து ஒரு டேப் ஓப்பன் பண்ணிட்டு அடுத்த டேப் ஓப்பன் பண்ணாங்க பேரல் ஆப்ரேஷன்ஸ் தான். ஸோ வந்து அந்த பேரல் ஆப்ரேஷன்ஸ் ரன் பண்ணணுன்றதுக்காக டெவலப் பண்ண லாங்குவேஜ் தான் ஹார்ட்வேர். ஸோ இப்போ சாஃப்ட்வேர் ரெண்டுமே லாங்குவேஜ் தான். சீக்வன்ஷியல் லாங்குவேஜ் இது வந்து பேரல் லாங்குவேஜ்.
மேக்ஸ் அந்த மாதிரி லாஜிக் நீங்கள் லாஜிக் கூட படிச்சிருக்கீங்க. அப்போ எனக்கு ஒரு இன்புட் வருது. அதை எங்கே நான் அந்த டேட்டா எடுத்து சிக்னல் எப்போ ஸ்டோர் ஆகணும், எங்கே அது எவ்வளோ ஸ்பீடில் ரிசீவ் ஆகணும், நெக்ஸ்ட்டு அந்த மாதிரி அந்த பேக் எண்டில் அது நடக்கிறதுக்கான எல்லாமே நான் கோட் எடுத்து இப்போ நம்ம கோட் எழுதி ப்ராசஸ் அப்போ தான் நம்ம வந்து அது எஃபிஷியண்ட்டாக ஒர்க் பண்ணணும். எனக்கு வந்து சில டைம் வந்து அந்த மெயின் மெமரியில் நான் டேட்டா ஸ்டோர் பண்ண மாட்டேன். கேட்ச் நீங்கள் எல்லாம் கேள்விப்பட்டீங்களா? அப்போ அந்த கேட்ச் எல்லாம் நான் தனியாக கூடியது. ஸோ எனக்கு வந்து மெயின் மெமரியில் போகும். எனக்கு கேட்ச் எழுதி எடுத்துருவேன். சீக்கிரமாக டேட்டா இதாக இது எல்லாமே இன்னும் அட்வான்ஸாக உங்களுக்கு ஏஐ வரும். CPU பண்ணுறவங்க CPU எல்லாமே பேக் எண்டில் சிபிசியில் தான் அது பண்ணுற மாதிரி.
சொல்கிற சில டாஸ்க்